We're going to be diving into a geometrical task using GeoGebra. We're going to be touching on parallel lines and angles of a triangle. So this task is going to be used for 8th grade math class, where we can see that some NC standards we'll be able to use is this one right here. It's just going to introduce the idea of congruence and rotations. And then we're going to see another one. This one's definitely more emphasized. We see the angle relationships in this standard, where students are going to be able to use informal arguments to analyze the relationships, such as interior and exterior angles, angles created with parallel lines cut by a transversal, and angle to angle criteria of similar triangles. Unfortunately, we did not see a real world problem. However, this probably meets the standard the best. So jumping back into it, just to kind of be quick, I see that students are going to be introduced to this, which I can create my own lesson and alter it if I want to. But we see an introduction image and a table of contents, where we're going to be able to do these two lessons. It's going to be a lesson and a practice section, which students can go ahead and click next, or they can come up here to the left and click on the corresponding assignment. So right here, we're going to see this idea that GeoGebra is given background information to our task at hand, and this is just going to be proved to be basic algebraic equations that students will solve and respond either true or false if they believe the question is correct. So as you can see right here, they get 3 chances to do this question. So if I go ahead and do 60 minus 30, I get 30, and then I do 62 minus 28, I believe that's going to be 34, so they are obviously not equal, but I'm going to go ahead and click true and see what happens. Check my answer, it is wrong. So I can go ahead and try that again. I can try it another time if I would like to, but I'm going to go ahead and click the right answer and see what it says. So we see it says correct. So that's going to be the same thing for each of these questions, just to introduce students so they can do this basic algebra, so that they may solve for unknown angles or midpoint or stuff like that. That's going to help us in this task. So as we can see here, GeoGebra has given us a little snippet of what they normally use, which is a grid and these manipulations for a triangle. So what we're going to look into is this question right here that teachers are going to pick out for their students, just to give the basic instruction. We see that triangle ABC here. We're going to want to select the midpoint tool and find a segment to do that. So what we can do is we can look at these different commands. So we see point, midpoint or center, rotate around a point, distance or length, angle, hide and show label, delete, or move, or we can zoom in and zoom out. So let's go ahead and zoom in just to get it a little bit bigger. So what we're going to do is we're going to scroll down and we see questions are being asked to the students. So it wants us to rotate triangle ABC 180 degrees around the midpoint of side AC. So let's go ahead and do, we want to do the midpoint of AC. So what we're going to do is we're going to click on midpoint. We're going to click A and C, and it's going to go ahead and give us that midpoint. So I'm going to go ahead and label this and click on our point. It's going to be labeled D. I could also hide that label by clicking on it again. So let's make it show up. So what the students want to do is we're going to be able to rotate around ABC 180 degrees. We're going to rotate it about this point. So I'm going to actually zoom back out. Or I can go ahead and move it into view if I want to. So I'm going to put it right in the middle. We're going to click on this, rotate around the point. I'm going to click on the figure that I want rotated, the point. I'm going to go ahead and type in the degrees that we're going to do. We're going to leave it counterclockwise, but we're going to go ahead and press OK and see what it comes out to be. So we see that same triangle rotated about this point 180 degrees. So it seems to have formed a quadrilateral, which this students will be able to kind of think for themselves, as it is a high cognitive demand task, so they can make connections and analyze the information that's given to draw conclusions using the manipulations given in GeoGebra. So in this, students are be able to use midpoint, develop segments, see rotation. They aren't able to see transformations like reflection, dilation, and translation. However, they're going to be able to understand that triangles equal 180 degrees, which we're going to see below. So as you can see here, it's super helpful that students are going to be given each question and they're going to be able to write it and type out their answer. Hello. Or they can go here and click on the equations. See that pi symbol? It's just going to go ahead and gives us functions, other letters, numbers, and symbols that they're going to be able to use. I'm going to go ahead and X that out. So we're going to scroll down here. And as I can create a lesson, I can alter any of these questions if I want to. But this is just one of these that's pre-made just for the teacher's help. So as we can see here, there's a triangle, and it has parallel lines, a transverse, and we can see that students are able to draw on it with a pen. They can go ahead and erase it, which that kind of takes long. So instead of doing that, I'm going to go ahead and click our back button. I believe it to be somewhere. Who knows? Anyway, we can go ahead and click a protractor and put that up here and drag and measure angles. There's a ruler, and we can change our pen color if we would like. So if I wanted to highlight an angle, I could highlight this angle B, or I could highlight this section. And here we can see that students are also able to draw shapes just to aid their thinking. Maybe if they knew a circle was 360 degrees, maybe this would help them. We could also see that they're able to access GeoGebra, mind maps, webs, PDFs, and stuff like that to help, or type out their answers if they want to. So let's go ahead and go to GeoGebra. And it goes ahead and gives us 3D calculators, graphing, all the basics that we're normally comfortable with, but I'm going to go ahead and click on geometry. So as you can see, it's that basic web page that we're normally attuned to. So that's really helpful for students to work out what they're thinking. So here we have more questions that students will answer. We have the angles added together. That's going to equal 180 degrees as we saw on our straight line. And they're able to build upon this question as it is a high demand task. Here, students are able to create, using the polygon tool, they're able to create quadrilaterals and measure it with a protractor so that they can determine the angle, and they can draw, so they can determine the angle of each section. So we can also use the back arrow to get rid of it if I make a mistake. We have erasers, or we can write in text. Yeah, hello. So they could put their answers on there if they would like to. So as we see, they have more questions below. And another one, so this is going to introduce that idea of alternate interior angles for on opposite sides of the transversal. And we're going to see the idea of congruent, same side interior, vertical angles, supplementary angles that are going to add up to equal each other. So right here, this would all be 180. So in this idea, we see that the triangles are kind of matched to form our squares, and we can see this idea of 90 degrees. And students are going to be given an angle right here, BAC, which is 53 degrees, and they're going to be asked to find as other many angles as they can. So they're going to be asked to give this one and kind of like use their problem-solving skills to develop this. So next we can go ahead and click on the practice. So I'm not going to really go through the practice because students are able to do this on their own after developing those skills. But as we can see right here, students are able to solve for the missing angle using the other two as we determine that a triangle equals 180 degrees. And they're able to use drawing, all the basics that we went over earlier. We have more questions where they type. And this basic diagram, which we already went over, but we just kind of hone in those skills where we see that Angle ABC is equal to 35 degrees. So I can go ahead and write that right here if I want to. 35. I know my handwriting's not the best. Or we could type it out if that would be better. Text. We want this to be 115 degrees. And I press OK. And that labels BAC, which is actually going to be right here. So then students can go ahead and solve for this angle, which we can see is also the vertical angle, and they determine all the rest of them. We can also go ahead and press that back button. And they're going to answer these questions, just kind of hone in that thinking. And right here we have a more in-depth question where students kind of get the chance to understand other ideas about angles using these tools. And yeah, and that will conclude our lesson for today. I definitely would use this in my own classroom or probably create it just to kind of simplify it a little bit. But I do believe it would take up a whole class period and just develop that high cognitive task for students to just understand these ideas and use technology at their disposal. Thank you for listening.